So let's work on the second half of this worksheet where it actually says solve the equation. If we look at number 19, it says 4k squared minus 28k equals negative 49. So let's set it equal to 0 so we could have a quadratic trinomial that's equal to 0. Maybe we could factor, split, and solve using the zero product property. So let me move the 49 over by adding 49 to both sides. So on the right side, yeah, the 49 cancels out. On the left side, you can't really cancel or add. You're just going to rewrite the whole quadratic trinomial with the 49 as your constant at the very end. So now at this point, you probably want to try to pull out a GCF, and you'll see that there's nothing in common in these three terms. There is no 4, there is no k, there is no GCF to pull out. So you might be thinking, well, maybe I need to go A times C and do that long process of factoring by grouping. However, you should recognize that there's a perfect square term right here in the front, and there's a perfect square term over here in the back. So maybe, just maybe, we'll be able to factor by taking the square root. Okay? So if I were to take the square root of 4k squared, what would I get? 2k? How about if I were to take the square root of 49, that perfect square term, what do I get? 7. So we have 2k and 7. Now, let's look at the signs. If I wanted a positive 49 at the very end, then this is either going to be a positive 7 times positive 7 or a negative 7 times negative 7. What's your guess based on the middle term, which is a negative 28? Negative and negative. So that's our guess right there, a negative 7 here and a negative 7 there. If we were to verify this by distributing 2k times 2k, that's 4k squared, 2k times negative 7, that's negative 14k, and then negative 7 times 2, that's negative 14k. If you add those two negative 14k's together, it really does work, so I know I factored it correctly. Okay? So now I'm just going to split them and solve. So I'm going to have the 2k minus 7 equals 0, and the other one's going to be the same exact thing. And if I solve it, I'm going to add 7 to both sides, and you'll get 2k equals 7, which means that if you divide both sides by 2, you get k equals 7 halves. Now, if you were to do that with the second binomial, which is the same exact thing, you'd get the same exact answer. Jumping to number 22, what confuses you on 22? That's right, the F word, fractions. So let's get rid of the fractions by multiplying everything by what? The denominator, right? Let's go with the biggest denominator, 9. So if I multiply everything by 9, 9 times g squared is 9g squared. And up here you could either say 9 times 2 is 18, and then 18 divided by 3 is 6g. Or you could cancel the 9 and the 3 and you'll have a 3 left over times 2, which is still going to give you a 6g. It's up to you. I want to cancel them and write a 3 left over, and 3 times 2 is 6g. And last but not least, the 9 and the 9 cancel. You end up with a plus 1 as your c value. And then, of course, equals 0 times 9 is still 0. So now at this point, we could focus in on this quadratic trinomial equation, and we could start doing a times c and get a number, then make a list of the multiples of that number and change it to 4 terms factored by grouping. But since we see a perfect square term in the front and a perfect square term in the back, maybe, just maybe, we could square root each of those, and we could put them into our factored form format, and we could get the factored form using the shortcut, the 2 cubes, or 2 cubes, what am I saying? Perfect squares shortcut. So here's the factored form parenthesis situation. The square root of 9g squared is 3g. The square root of 1 is 1. So we have 3g and 1. And let's look at the signs. If the last term is positive 1, it's either going to be positive 1 times positive 1 or negative 1 times negative 1, right? So it's going to be, looking at your middle term, everything's positive, so you are going to have a positive 1 times positive 1. Of course, you're supposed to double check, distribute, and see if it actually does work and give you the middle term 6g, which it does. But anyways, if you split them and solve, you're going to have 3g plus 1 equals 0. And you could split this one, 3g plus 1 equals 0. But what's the point of that? Because you're going to get the same answer 2 times. So what's your answer going to be? It's simply going to be subtracting 1 on both sides. You're going to have 3g equals negative 1. 3g equals negative 1, and then dividing by 3. So your final answer is g equals negative 1/3. 2 times. So g equals negative 1/3 is your answer. Now number 26 is an interesting one, because 26, we have h plus 9 squared, and we want to solve for h. Now we want to get rid of this square so we could get h by itself. So technically we want to get rid of everything on the left side of the equal sign except for h. Now I need to get rid of the square first. How am I going to get rid of something? By doing the opposite. If there's a fire, turn it off with water. If you have a square, how do you get rid of a square? With a square root. But what you do to one side, you must do to the other, so you're going to square root over here, the 3. So what are we going to have left? We're going to have h plus 9 equals, now remember, if you apply a square root in an equation, you have to have a plus or minus right in front of your answer. In this case, the square root of 3, I can't do it. I'm just going to leave it like that. My final step to get h by itself would be to subtract 9 and subtract 9. You can't really subtract 9 from a radical, so let's just leave it h equals negative 9 plus or minus the square root of 3. Let's jump back to 23. What do I do to get rid of the fractions? Multiply everything by 25 would be the best option. Right? Go with the bigger denominator first. Multiply everything by 25. When I say everything by 25, I'm talking everything, even the 0 by 25, everything by 25. So 25 times p squared is 25p squared. And then over here, instead of saying 25 times 6, I'm going to divide the 25 by 5, and I'm going to actually have a 5 left over up on top. So 6 times 5 gives you 30p. The next one's super easy. The 25 cancels with the 25. So you're going to have a plus 9 left over. And of course 0 times 25 is 0. Right here, once again, I recognize that I have a perfect square term in the front. I have a perfect square term in the back. So maybe I could factor using the shortcut. Maybe. I mean, I still need to verify it, right? So what is the square root of 25p squared? 5p. What's the square root of 9? So you have 5p and 3. Now let's think about the signs that belong there. If it's a positive 9, then it's either going to be positive times a positive to give you a positive, or if it's positive 9, it'd be a negative times a negative to give you that positive 9. So are these signs going to be minuses or both pluses? Based on the middle term, it's minus, which means that these guys are also going to be minus. So we're going to have 5p minus 3 times 5p minus 3. Now if you verify that, it does work, because 5p times negative 3 is negative 15p, and negative 3 times 5 is another negative 15p. When you combine both negative 15p's, it does give you negative 30p. So when you split them, you get the same equation 2 times. So let's write down our answer. By adding 3 to both sides, you're going to end up with 5p equals 3, which means that your final step will be divide by 5, which means p equals 3/5. P equals 3/5. And if you did that with this equation, you get the same exact answer. So I'm just going to write the answer as one answer, p equals 3/5.